Adolescence is a time of dramatic change in every aspect of development. Research over the past decade on the development that occurs in the adolescent brain allows us to begin to understand from a molecular and cellular level what is happening to produce those frustrating, scary, and ultimately life-affirming behaviors that we see in adolescence. The brain is composed of at least two major systems that help to govern our lives: the social and emotional system and the cognitive or thinking part of the brain. The goal of the development of the adolescent brain is the achievement of a balance between these two systems that can at times challenge each other for dominance. Adolescence is the product of an imbalance in these two systems of the brain, leading to the behaviors that we typically see in adolescence. How does the brain work? The brain works because individual nerve cells or neurons are constantly communicating with each other. The way that we communicate is that I'm using words right now. The words come out of my mouth, they fly through the space in the air, into your ear, gets processed in your brain, and you receive a message from me that I sent via my words. The way that the brain communicates with each other is that each individual neuron releases chemicals. So the first neuron at the bottom releases chemicals that are represented by the yellow circles there, that travel through space called a synapse in between the nerve cells. And there are little receptors, similar to our ears, on the other nerve cell that the chemical attaches to and sends a message to the next neuron. That message then tells that neuron to send another message or to make some change or to start to create some kind of protein that allows our brain then to function in the higher behaviors that we see now. The chemical that I want to talk about most today is a chemical called dopamine. Dopamine is a chemical that's used by certain neurons in the brain that are associated with reward, reinforcement, and also with fear and remembering what's important in the environment to remember. So dopamine is released by certain neurons in response to certain stimuli from the environment, such as food, such as interesting new experiences, such as sex, and certain drugs. And even the thought or stimuli associated with those things can cause a release of dopamine. For example, if you like chocolate chip cookies, and the fact that I just said chocolate chip cookies, your brain just released some dopamine in anticipation of the reward of eating a chocolate chip cookie. That same release of dopamine can happen in response to many different things, again, in the environment. The system that's most associated with the release of dopamine is the social emotional system, which I mentioned just now. Dopamine neurons are mostly seated in that social emotional brain, and the key component, the core of that social emotional brain, is a collection of neurons called the amygdala. The amygdala is present in this schematic. This is a brain. The right half of the brain was removed, and you can see the internal structures of the brain. And the amygdala, there's one on each side of the brain, are lit up in this slide. What the amygdala does is that those neurons are responsible for processing fear, anger, pleasure, and again determines what memories are stored in our brain. So, for example, if there's something that's really important to remember about the environment, it's the amygdala that's going to tell your brain, you need to remember this. So, if I were walking across the stage and a poisonous snake slithered across the stage, my amygdala would fire off and say, first of all, watch out, there's a snake, you need to run. But secondly, it would say, you need to remember this stage because this isn't a very safe place. So the next time I got onto the stage, my brain needs to remember that I need to watch out for snakes. And so that's one of the components, one of the tasks that the amygdala does. The amygdala is very well connected to the rest of the brain as well. So any sensory input that comes in from the environment is connected to the amygdala, obviously, because if I see a snake, it needs to be connected to the part of my brain that's going to tell me what to do about that. It's connected very intimately with the parts of the brain that are responsible for the physical changes that happen when we're experiencing something that causes fear or pleasure. And so that would be, in the case of fear, it would cause my heart to start beating faster, my muscles to be ready. I would start to sweat in anticipation of needing to run or fight. It's also very much connected with the frontal cortex, which is the part of the brain that's the thinking brain. And that's a very important connection that I'll talk about a little bit later in the talk. And when I say that the amygdala is connected with other parts of the brain, what do I mean by that? What I mean is that there are neurons that extend from the amygdala that connect with neurons in other parts of the brain, and they communicate by the chemical dopamine. And so when that neuron releases dopamine to send a signal, the signal is often related to a reward, such as, ooh, that cookie was good, I want another one, which then sends a signal back to my arm to reach out and grab another cookie and eat it. Or in the case of fear, it says, you need to be ready to run or fight or jump. The first major development that happens in the adolescent brain is a restructuring of this dopamine system and the reward system. So what we see is that the number of receptors, those ears on the other neurons that receive the message, the number of those receptors increases in children up to the age of about 8 or 9 or 10. And then at that point, what we see is that those receptors, the number of receptors, start to decrease, especially in boys, but also in girls. And the important concept to remember about that is that in brain development in general, it's not necessarily the amount of receptors or the number of receptors, the amount of chemical that's released, the size of the brain in terms, it doesn't necessarily mean that that brain is more developed or more active. What matters is how efficiently the brain is operating. And so what we see as a result of the decrease in dopamine receptors is that that's caused by that brain making the most important connections. And so if you like chocolate chip cookies, but you also like some other cookies, sugar cookies, ginger snaps, other things that aren't as important, the connection for chocolate chip cookies is going to be the most important. It's going to be the strongest, and that's going to be the one that's most activated when someone says cookies. And so what happens as a result of this restructuring is that those dopamine connections are much more active, they're much more efficient, and therefore they're much more rewarding when dopamine actually does get sent as a signal. That signal is much stronger, resulting in the feeling of a much greater reward, which is why when dopamine says jump and an adolescent jumps off a cliff into water, it's very rewarding because that's a new experience, and the dopamine has sent a message to say this was fun, this is a great experience, let's do it again. So because of this is why we see adolescents start to take huge risks and start to look for more things for sensation. Beginning at about the age of 10 and peaking at ages 13 to 16, we see an increase in risk-taking activities, in looking for sensation, and in reward preference, meaning adolescents would much prefer getting a reward now than having to wait longer. I guess all of us would do that, but adolescents certainly, the draw for an immediate reward is much more powerful in adolescents because of this preference for of the dopamine system. So increased dopamine activity means that the pleasure center of the brain is more active and more powerful. And the way that the brain learns through neurons is that, again, to use the chocolate chip example, when I mentioned chocolate chip cookies, the neuron releases some dopamine, it anticipates a reward, you eat the cookie, it's a reward for you. But over time, the power of that system starts to decline such that chocolate chip cookies over time aren't as rewarding as they were the very first time you had one. What this means is that when you do have an unexpected reward, that level of dopamine release and the sensation of reward and pleasure that you get from that is much more powerful. And so that helps to explain why adolescents are constantly seeking out new sensations and being driven out into the world to try to find something new and exciting, because that reward is so much more powerful for them. Basically, what happens is that adolescents are not necessarily less knowledgeable about risks, but they do attach much greater value to the rewards that risk-taking provides. So if you were to look at this mouse as an adolescent mouse, first of all, it would never happen because to get a helmet on an adolescent is almost impossible. But the point is that this adolescent put a helmet on because he knows that there's risk associated with getting this cheese. That trap could snap on his head, could really cause injury or death. That mouse could tell you that that's potentially what could happen. However, the reward of getting that cheese is so much more powerful for an adolescent that they're going to risk going for it. And not only is the reward of the cheese such a great reward, the actual act of taking the risk is also a reward. Even if the cheese weren't there, the fact that you're taking a risk is a reward for an adolescent.